So find the number of permutations of the letters in the word kitchen if the letters K, C, and N must be together, but not necessarily in that order. So we look at the word kitchen. Does it have any doubling letters? No, not yet. And how many letters does it have? 7. So we are rearranging 7 letters, right? Because it didn't tell us any less. So we do 7. The stipulation they gave us is that K, C, and N must be together. So I'm going to hook them together. I always hook them together at the front just because that's how I like doing it. Does it say in the order KCN? Because if it was in the order KCN, it would be 1, 1, 1, correct? But it's not. They just need to be together. So what options do I have for this first blank? K, C, or N. So it's 3. And then words are non-repetition. So then I would have KC, which is 2. And then I would have C, which is 1. How many letters did I use up? 3. How many do I have left? 4. So I'm going to have 4 left for here, then 3, then 2, then 1. Now this would be correct if they said KCN together at the beginning. Did they say that? No, they just said KCN have to be together. So we're going to look at, up here, other ways that KCN could be together. So we hooked KCN together here and we had 3, 2, 1, 4, 3, 2, 1. We agree? But could we not put them between these 2 letters here? Would they still be together? Yeah, so we could go 4, 3, 2, 1, 3, 2, 1. Could we put them between these 2 letters? Yeah, so we could go 4, 3, 3, 2, 1, 2, 1. We could put them between these 2 last letters. 4, 3, 2, 3, 2, 1, 1. And we could put them behind that last letter. 4, 3, 2, 1, 3, 2, 1. We agree? So we literally just have 3 letters together, and we could take them here. We could put them between these 2 letters here, or these 2 letters here, or these 2 letters here, or at the back, right? And they'd still be together, would they not? And they would make different words, would they not? Because the order would be different. Okay. If I multiply each one of those separately, do they give me the same number? 4, 3, 2, 1 times 3, 2, 1, 3, 2, 1 times 4, 3, 2, 1. Because you're just multiplying all those numbers, it would get you the same answer, right? So how many of these are there that are the exact same? 5. So could I not just take one of them and multiply it by 5? Yeah, so that's what we're going to do. So it's always one more than this number here, because they could be here, which is one way, or here, which is 2, here, which is 3, here, which is 4, or at the back. So we're always going to multiply by 5 because I can move it into 5 different spots, right? Does that make sense? If I move it into 5 different spots, so I could do that each time, which would take forever, or I can know, hey, I can move it and multiply it by 5. Make sense? So this is the same as saying 3 factorial, because 3, 2, 1, times 5, 4, 3, 2, 1, which is 5 factorial. What's 3 factorial times 5 factorial? 720? Okay. Before we look at B, I want you to answer this. So if I said to you, tell me how many people are in this school but not in this classroom, what would the fastest way be to do that? How many people are in this school but not in this classroom? Yeah. Quinn? Yes. And then what would be left over are the people that are not in this classroom. You're correct. So when they ask us to rearrange kitchen, What's the total amount of ways we could rearrange kitchen if there was no restrictions? Rearrange the word kitchen, 7 letters. 7 factorial, right? Be 7 in this blank, 6, then 5, then 4, then 3, then 2, then 1, correct? So the maximum number of ways, so total no restrictions, ways you can rearrange kitchen is 7 factorial, which is 5,040. So maximum rearranging kitchen, if I wanted to come up with different words, the maximum number of words I could come up with would be 5,040, correct? Could I somehow find a 5,041 word? No. Maximum is 5,040. Maximum number of kids in this school, 835. Okay? Can I find an extra kid and invite them along? Sure, but they're not in here right now, so not allowed. Okay? Kitchen, maximum number of words, 5,040. Maximum number of kids in the school, 835. Okay? Now, this question in particular wants us to state the number of permutations, arrangement where order matters, of the letters in the word kitchen if the vowels can't be together. So if I take the order of the kitchen, which is 5,040, right? That's maximum, or sorry, yeah, 5,040 is the maximum number of ones I can do, right? We agree? And I subtract off all the ways I put the vowels together. What am I left over with? All the ways the vowels can't be together, right? Because what's the opposite of the vowels being together? Not together, right? So the total number of words is 5,040. Is that 7 factorial? Is that correct? 5,040? Check my math. Yeah? So if I take the total no restrictions, subtract off the vowels together, it equals vowels not together. Okay? So 5,040 is the total number of ways I can do kitchen. Now I'm going to do vowels together. How many vowels are in the word kitchen? There are 2. So I'm going to hook 2 together, right? How many options do I have for my first blank? 2. How many for my next blank? 1. And then how many letters do I have left? 5, 4, 3, 2, 1. Is that all the ways? 2 times 5 factorial, all the ways that I can keep the vowels together? No, what am I forgetting? To multiply it by 6, because it's always 1 more than this number, right? So this is 1 way, 2 ways, 3 ways, 4 ways, 5, 6. So it's 1 more than this, so I have to multiply by 6. So it's 5,040 minus 1,440. What's 5,040 minus 1,440? You need to know how to do these questions where it says not together. You need to know how to do them. Okay? They're fair game. I want you guys to try example 2, 3, 4, 5, and I'm going to put a 6th example. Okay? 2, 3, 4, 5, and I'm going to put a 6th. Try them out. In how many ways can all the letters of the word oranges be arranged if there are no further restrictions? Oranges. 7 exclamation point, so 7 factorial, which is 5,040. The first letter must be N. So we have N here, which is 1, then 6, 5, 4, 3, 2, 1. So 6 factorial, which is 720. And this one says the vowels must be together in the order O, A, E. So they have to be in the order O, A, E. So 1, 1, 1. Then we have 4 letters left. 3, 2, 1. And then we multiply by 5. Because it doesn't say vowels at the beginning, so they could be here, which is 1, 2, 3, 4, 5. In how many of the arrangements of the words brains are the vowels together? So there's 6. How many vowels? 2. Does it say any specific order? No, so this could have how many? 2 and then 4, 3, 2, 1, and we're done? Times 5. Because you can move 5 places, so 240. In how many ways can 3 girls and 4 boys be arranged if no 2 people of the same gender can sit together? What do we have to start with if we don't want them to sit together? What gender? The boys. So we could do boy, 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 girl, girl, girl. So the boys, you'd have 4, 3, 2, 1. And the girls, you'd have 3, 2, 1. The blue makes up 4 factorial, and the green makes up 3 factorial. Six actors and 8 actresses are available for a play with 4 male roles and 3 female roles. So we have 4 male roles, and then we have 3 female roles. And it has the word and. So we're going to multiply them, correct? Because if not, you're saying I want the 4 male roles or the 3 female roles, which is that what you want? No, you want both, so you have to multiply. So these are the male roles. There's 6 actors, so 6, 5, 4, 3. And then the female roles, there's 8 actresses, so 8, 7, 6. And what does that equal? 6 times 5 times 4 times 3 times 8 times 7 times 6. Sorry, 120,000. The last one. Put your hand up if you started with boys first. Okay, put your hand up if you started with girls first. You actually have to do both. Because, which most people only do one. 1, 2, 3, 4, 5, 6, 7, 8. Boy, 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 boy. And then girl, 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 girl is a total different picture than girl, 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 boy, 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 boy. You have this case or this case, so you could add them. Or you could say, hey, I know that they're going to equal the same amount, so I could just times it by 2. Yeah. So 4, 3, 2, 1. 4, 3, 2, 1. 4, 3, 2, 1. So it'd be 4 factorial times 2, which I don't know what that is. Pardon? Thanks. I got the 1,000 and then the rest just mushed. Okay? Flip over. Now we have words with repetition, like basketball. So if we look at the 2 words basketball there, do they look exactly the same? Yeah, I swapped the 2 L's. Can you tell the difference? No. I swapped the B's now. Can you tell the difference? No. So the catch is that we have to take into account those double ups, right? So the first thing you want to do whenever you get a word, up till now we haven't had to worry about it, but what you want to do when you get a word is write it out. So B, A, S, K, E, T, B, A, L, L. And the reason why you want to stack it is when you stack it, you might think, why am I stacking this? Oh, right. I'm going to deal with those double ups. Okay? So on the top, you treat it just like you would if the word had all different letters. And then there's a really quick way to get rid of all of the double ups. Okay? So, how many letters are in the word basketball? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct? So if I were rearranging basketball and pretend all the letters were different, I do 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Correct? So I'm going to still do that, which is 10 factorial. But we know that there are some doubling words, right? If I just swap the L's, it looks exactly the same. If I swap the B's, it looks exactly the same. So how you fix that really quickly is you divide by whatever the factorials are. So I have 2 B's, 2 A's, 2 L's. So I'm going to divide by 2 factorial for the 2 B's, 2 factorial for the 2 A's, 2 factorial for the 2 L's, and I'm going to put it in brackets. Okay? If you do not put it in brackets, the denominator, what it is going to do then is your calculator is going to do order of operations because that's what its default is, okay? So it's going to go 10 factorial divided by 2 factorial, take that answer, multiply it by 2 factorial, take that answer and multiply it by 2, which actually makes it bigger, not smaller, correct? They will have that answer on your diploma. Because common error is to not bracket those, okay? So when you do this, you have to make sure you divide. So you divide by 6, not 2, and then multiply by 4, okay? So what's 10 factorial divided by 2 factorial, 2 factorial, 2 factorial? What do you get? Okay, we're going to look at aardvark. So if they just wanted us to rearrange aardvark without any restrictions, we have A, R, D, B, A, R, K. Aardvark with no restrictions would be 1, 2, 3, 4, 5, 6, 7, 8. It'd be 8 factorial divided by 3 factorial, 2 factorial, correct? Without any restrictions, you do 8 factorial for the 8 letters divided by 3 factorial, 2 factorial. Not 6 factorial, or I mean 5 factorial. Some people put them together and then say 5 factorial. That doesn't work. 5 factorial is 120. 3 factorial times 2 factorial is 12. They're not even the same. Okay? So the factorial symbols you have to do separate for each letter. Okay? So this one would be 8 factorial divided by 3 factorial, 2 factorial, but it's not because they gave me some restrictions on this. They say the A's must be together. Aardvark is 8 letters. 1, 2, 3, 4, 5, 6, 7, 8. The A's must be together. You know what I'm going to do right away? I'm going to put on the bottom 3 factorial, 2 factorial. For the A's and the R's. I have 3 A's and 2 R's, right? So on the bottom, I'm going to do that. On the top, I'm going to treat them like they're all different. We agree? Like I can tell the difference between the A's. Can I? No. And I should have clicked together 3 letters because there's 3 A's. I just seen that. Okay. So we're treating the A's as if they're different, correct? So how many A's do I have for the first blank? 3. How many for the second? 2. Then? How many letters left? 5, 4, 3, 2, 1. Is that everything? What do I have to remember to do? Move it 6 times, right? Because it says together, it doesn't say at the front. So they could be here, which is 1 way, or 2, or 3, or 4, or 5, or 6. So on the top, I have 6 factorial, 3 factorial in brackets, divided by the bottom, 3 factorial, 2 factorial. What's great about this one? Those would cancel. So it's going to be 360. Okay? You guys try B and C. B and C, and then we're going to do these, and then you're done for today. So this one must start with the V's. So Vancouver, V-A-N-C-O-U, V. ER. So there's 2 B's. Vancouver has 9 letters. We're going to have a 2 factorial in the denominator because of the 2 B's. So you don't have to think of what you put in the denominator. You just put the doubling, tripling in the denominator always, right? They'll have the answer to it if you forget the denominator as well, right? That'd be their go-to oopsie answer. Must start with the V's. So I have 2 V's. So 2, 1. Can I move them at all? Does it say they have to be together? It just says they have to start. 7, 6, 5, 4, 3, 2, 1. So it's 5,040. Mathematical vowels must be together. M-A-T-H-E-M-A-T-I-C-A-L. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wow. Two factorial for the M's, 3 factorial for the A's, 2 factorial for the T's. Vowels must be together. We have A, 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 E, I, so 5 of them. So we have 5 options, 4, 3, 2, 1. Then 7. And I'm done. No, what did I forget? Put them in all the different spaces. So I have to multiply it technically by 8. 8? You have me questioning myself. 8. Yeah. So you get an answer, of which I don't know what it is, but that's okay. 201,600. Okay, put your pencils down. You're going to pay attention to example 3. Example 3 is a pathways question. With pathways, they want to go from A to B. They're not allowed to like loop back. They can't go like over here, then back up, then back to A. This would be just, they're stupid. Infinite. They're just circling the drain. Can't, okay? We're trying to find the path of least resistance. So they have to go to A to B. They can't backtrack, okay? You're paying attention because I'm not going to actually ask you to do it this way. But I'm going to prove to you it works by doing it this way. So to get to this path, there's one way, right? I walk along it. We agree? To get to this piece of the path, there's one way. To get to this piece of the path, there's one way. I walk down to it. To get to this piece of the path, there's one way. I walk down to it. To get to this piece of the path, one way. Go from here, walk down. Correct? To get to this piece, 1. To get to this piece, 1. To get to this piece, 1. All these edge ones are just 1. Now what we're going to do is we're going to sum them up as we go along. Okay? So 1 path in, 1 path in. I have a total of 2 paths that get me to that spot, correct? Just give me this spot. 1 path in, 2 paths in. I have 3 paths to come into this spot. 1 path in, 3 paths in, 4 paths total to get me this spot. 1 and 4, 5 to get me to this spot. 2 coming in, 1 coming in, 3 to get me this spot. 3 and 3, so 6. 4 and 6, so 10. 5 and 10, 15. 3 and 1, 4. 6 and 4, 10. 10 and 10, 20. 15 and 20, 35. 4 and 1, 4, 5. I'm going to multiply. 5 and 1, 6. 1, 5, or 10 and 5, 15. 15 and 6, 21. 35. 56. 35 and 35, 70. 70 and 56, 126 different ways that the people could walk from A to B. Okay? There's 126 total paths. But does this fit anywhere into perms and coms, the way I just did that? No, we're just doing it as pathways. Well, it does fit into perms and coms if I treat these as letters. So I have 1 down, I have another down, I have another down, I have another down, and I have a right, a right, a right, a right, a right. So if I pretend that I'm actually doing the word der, okay? If I was rearranging the word der, how many letters does it have? 9, technically, right? It has 9. So what do we do when we have words like der? On the bottom, we'd put 4 factorial, 5 factorial to represent the fact that I have 4 D's and 5 R's. We agree? And what do I do on the top? I just pretend that they're all different, correct? So how many letters do I have? 9. So I'd go 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or what is that? 9 factorial. Divide those out. Bless you. 126. This one here has 2 blocks, right? So I'm going to do de, and then I'm going to do de, Very different. Right? Because they're 2 separate blocks. So what would be the answer to this one? On the bottom, I'd have 2 factorial for the D's, 2 factorial for the R's, and what would I have on the top? 4 factorial. For this one, I'd have 2 factorial for the D's, 3 factorial for the R's, and what would I have on the top? 5 factorial. The hardest part about this is deciding whether you multiply them or add them. Now think, do I need to go through these paths and these paths to get me to B? Or can I do these paths or these paths and I'll get to B? And or. And. Or would mean that I could do these pathways and I could miraculously jump somehow from there through the time machine to B. Can we do that? Or I could overcome and jump all of the ones up here, just land into the second half and get to B, right? So I need these pathways and these ones to get me through the whole thing, okay? So I always multiply them. And if you forget, what connects them? A dot. What does a dot represent? Multiplication. Did someone get the answer? What is it? All I hear is a lot of whistling from quiet talking. Does anyone know? This is not any better, guys. 6D. Total? Okay, I believe you. 1, 1, 1, 1, 2, 3, 3, 6, 6, 6, 6. Ooh, devil. 12, 18, 24, 18, 36, 60. Yeah, you're correct. You don't need to do that. It used to be in 30 applied. Okay. Flip over the page. Homework. For shame. There's work.